You guys are starting a unit on electricity and you just finished one up on static electricity, and I want to show you how the two are related. And they're related through this thing called voltage, and you guys are just starting to look at that. So let's back up a minute to the electric field. When you rub two objects together, those two objects became charged, and because of that, the two objects could interact with each other without actually touching each other. So they're capable of exerting forces on each other without touching. And that's because these charged objects create a region of space around them that exerts a force on other charged particles. So if you think about a big positive charge, what we do is we draw an electric field and we represent this as arrows that point away from it. And basically we point the arrows away from it because if we brought another positive charge up next to it, there would be a force on this positive charge away from this one. Okay, so these lines represent electric field lines. And the stronger the electric field is, well, the strength actually depends on this central charge, and it depends on how close we are. If these two charges are really close, then the forces that they feel are pretty strong. If they're far away, then the forces are weaker. So the bigger the charge, the stronger the field, and the closer the charge, the stronger the interaction. Now this actually leads to some cool things with work and energy. Okay, if we have a charged plate over here, so this thing has a big positive charge, plus, 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 and we have another charged particle, a positive proton, whatever. Okay, well there's an electric field straight away from this plate. It's going to push on any kind of charge that comes towards it, which means if I want to push this charge this way up close to that field, I have to do work. Now work occurs when an object exerts a force through a distance, or when a force acts on an object through distance. So if we force this object closer and closer and closer to the plate, we're doing work. And that transfers energy. It transfers energy to that proton, because if we move it to here, it's now unstable. It has potential. It has potential to change. It has potential to move this way, especially if there's a negatively charged plate over here. So what these two plates have done is they've created a difference in potential energy for this charge. Down here it's got very little potential energy because it can't really fall any further towards this negative side. Up here it's got lots of potential energy because it's being pushed by this one and pulled by that one. So when we separate charge, we create this electric field which creates a potential energy difference, or a potential difference, and that's actually what we call voltage. Voltage is a potential difference when an object is placed in a field. So right here I have my separation of charge, plus minus, plus minus, plus minus, and then I have charged particles in here. Now if this charged particle is a big charged particle, then it's going to interact with the field more strongly and it's going to feel a greater force. It's going to have more potential energy. If it's a little charged particle, then it interacts less strongly. It's a weaker force acting on it and it has less potential energy. And because of that, instead of giving this as absolute energy, we give it as energy per unit charge. And so what that means is this potential difference, this voltage, is defined as joules, which is a measure of energy, per coulomb, which is a measure of charge. Now, what that basically means is if we have lots of energy, or this field is really, really strong, we're going to have high voltage. You can compare voltage to height, and what I mean by that is if you have a rock or boulder or whatever, you can give it more energy by lifting it a higher distance. The greater the voltage, the greater the energy it has. It's got a bigger field to move through. Okay, so if we drop the rock from here, it smashes into the ground. It doesn't smash as hard as if it falls from that height. So voltage is a measure of potential, or electric potential energy, and really it's because of a difference in an electric field.